Imagine a landscape so broken, so scorched by the sun, that nothing but razor-sharp invasive grass can grow. This is the Guanacaste province in Costa Rica in the mid-90s. It wasn't a forest. It was a desert of dead pasture. But in 1997, a convoy of 1,000 heavy trucks rumbled into this wasteland carrying something unexpected. They weren't carrying seeds, or soil, or water. They were carrying trash. 12,000 tons of sticky, rotting, acidic orange peels. The masterminds were Daniel Jansen and Winnie Hallwalks, two ecologists who made a radical deal with a local juice giant, Del Oro. The deal was simple. We will take your industrial waste for free if you dump it exactly where we tell you. It sounded insane. Why would anyone want a mountain of garbage in a conservation area? The plan was to use this biological bomb to nuke the invasive grass that was choking the life out of the soil.
We need to act now.
When the dumping stopped, the sight was repulsive. 3 hectares of land were buried under a foot-thick layer of citrus sludge. It smelled of fermentation and decay. It attracted clouds of flies so thick you could hardly breathe. To the average observer, this wasn't conservation, it was pollution. But underground, a chemical war was beginning. The massive influx of acidic peels began to suffocate the invincible Jaragua grass that had dominated this land for decades. But the experiment was too bold for its time. A rival fruit company, Tico Fruit, saw this free waste disposal and cried foul. They sued Del Oro, claiming the project was defiling a national park. The media turned against the scientists. The public was outraged. In a crushing verdict, the Costa Rican Supreme Court ordered the project shut down. The ecologists were kicked out, the gates were locked, and the 12,000 tons of peels were left to rot in disgrace. For the next 16 years, the site was abandoned. No one touched it, no one watered it, no one planted a single seed. The world moved on. The sign marking the site rusted away, and the location was erased from local memory. But while humans argued in courtrooms, nature was busy working in the dark. The rotting peels were dissolving, seeping into the cracked earth and preparing a miracle that no one would see for nearly 2 decades. Flash forward to 2013. Princeton researcher Timothy Troyer returned to Costa Rica to find the old experiment. He had the GPS coordinates, but he thought his device was broken. He was looking for a pasture, but he was standing in front of a wall of green so dense he couldn't walk through it. He had to use a machete to hack his way in. The wasteland was gone. In its place was a jungle. Troyer couldn't believe his eyes until he looked across the road. On one side was the control plot, the land that was never touched. It was still a hot, dry, grassy desert with barely a few scraggly bushes. On the other side, where the oranges were dumped, a thriving, multi-layered rainforest. The contrast was so sharp it looked like a glitch in the matrix. One side was death, the other was life. How did this happen? Troyer dug into the soil to find out. The results were shocking. The original soil was highly acidic and nutrient-poor, hostile to life. But the orange peels, though acidic themselves, had decomposed into a nutrient-rich organic layer that buffered the soil. Over time, this transformed the chemistry, neutralizing the harsh conditions and creating a pH balance perfect for native trees. It wasn't just pH. The soil analysis revealed a massive spike in essential elements. The orange-treated soil showed significantly elevated levels of macronutrients like nitrogen and phosphorus, and micronutrients like calcium and zinc. The peels didn't just sit there. They became a super fuel. This agricultural waste had injected the earth with exactly the cocktail of vitamins the forest needed to wake up. The most incredible finding was the diversity. In the untreated pasture, there was basically one species, the invasive grass. But in the orange forest, they counted over 24 different species of vegetation. It was a botanical explosion. Native fruit trees, hardwoods, and vines had all returned. The peels didn't just grow trees, they invited an entire ecosystem back to the party. This diversity created a protective shield. The new trees grew broad, thick canopies that cast a deep shade over the forest floor. This shade did two things. It starved the sun-loving invasive grass, killing it off for good, and it kept the ground moist. In a region plagued by wildfires, this orange forest became a natural firebreak. While the grass outside burned, the moist, shaded forest stood safe. Where the plants go, the animals follow. The research team found that the biodiversity of the agricultural products, the wild fruits and seeds, had attracted a zoo of creatures. They found tracks of the tyra, a large weasel-like predator, and spotted rare birds nesting in the canopy. The silence of the dead pasture had been replaced by the roar of the jungle. Life had returned to the graveyard. Standing in the center of this miracle was the ultimate proof, a wild fig tree. In just 16 years, it had grown into a giant. Its trunk was 3 feet wide, and its roots sprawled across the ground like ancient pythons. A tree this size usually takes decades, perhaps a century, to grow. Fed by the orange compost, it had sprinted through time, becoming the king of this new forest. The numbers were crunched, and they were staggering. The area treated with orange peels had a 176% increase in above-ground biomass compared to the control plot. That's nearly triple the amount of wood, leaves, and life. It is, to date, one of the most successful forest restoration projects on the planet, and it cost almost nothing. It was literally powered by garbage. But this story is bigger than Costa Rica. We live in a world desperate to capture carbon. These orange-fed trees are now sucking tons of CO2 out of the atmosphere every year. Scientists call this cost-negative carbon sequestration. Usually, saving the planet costs billions. Here, the industry actually saved money by not building a waste processing plant, and the planet got a free lung. The success was so undeniable that it started a revolution. Costa Rica began applying the lesson to other industries. In 2021, they tried it with coffee pulp, another acidic, troublesome waste product. They dumped 30 truckloads onto another dead pasture. The result? The exact same miracle. The coffee pulp smothered the grass, fed the soil, and birthed a forest in record time. The challenge for us now is to understand the mechanism. It wasn't magic, it was biological leverage. The orange peels did the hard work that humans couldn't afford to do. They provided the mulch to hold water, the acid to kill the competition, and the food to feed the microbes. It challenges the traditional view of conservation that says nature needs to be protected from human waste. Sometimes, nature needs our waste. Imagine the potential. The world produces over 1 billion tons of agricultural waste every year. Much of it ends up in landfills, creating methane gas. What if we diverted that waste to the edges of the Amazon, to the deforested savannas of Africa? We could turn our biggest trash problem into our biggest climate solution. We have the peels. We just need the courage to dump them. This project challenges us to rethink the word pollution. Is an orange peel pollution? Or is it a resource in the wrong place? In a landfill? It's a hazard. On a degraded pasture? It's gold. The 12,000-ton mistake taught us that nature doesn't hold grudges. It is ready to forgive our destruction if we are just willing to give it the fuel it needs to rebuild. The forest of Guanacaste stands today as a living monument to a bold idea. It is a dense, wild, chaotic jungle built on a foundation of juice leftovers. It reminds us that sometimes The best way to move forward is to look at what we leave behind. And this was the story of the orange miracle.